Syphilis, one of the oldest known sexually transmitted infections. This disease starts with mild sores and rashes, but can escalate to severe symptoms like heart complications, brain damage, and paralysis if untreated. Scary, but wasn't that over by the 90s? CDC data highlights a worrying trend. Once thought to be in decline, syphilis is now resurging at an alarming rate. The syphilis rates in the US started going up in 2000 and haven't stopped since. By 2022, reported syphilis cases soared to over 207,000, dramatically exceeding the 37,000 cases reported in 2002. That's a 530% increase in cases over the past 2 decades. According to Johns Hopkins University, we should be able to eradicate this entirely preventable disease through the basic tenets of infection control. But there are wider public health challenges. Screening is inadequate. With the guidance of our sponsor, Professor Pan, and his associates Teresa and Ketan, our team of talented undergraduate engineers set out to create a first-of-its-kind electrochemical point-of-care test.
Currently in Professor Pan's lab, by conducting a multi-stage process with a qualified professional who can understand the graphs and determine a result, Treponema pallidum can be extracted and chemically identified to determine if a patient has syphilis. Our team is streamlining the process, condensing it into a user-friendly device. Within 10 minutes, it should present a positive or negative result while appropriately handling contamination risk. Here's how our final product works.
Swab the inside of each cheek. Open the DNA column and swirl the swab. Recap the column. Unscrew the bottom cap. Place the DNA column on top and remove the cap, letting the liquid drain into the methylene blue container below. Slide the sample processor into the test. Insert the biosensor chip into the device. Turn the clamp to the designated position. The solution will exit at a steady drop-by-drop rate. Close the clamp to stop the liquid flow. Once the process sample is on the chip, then the electronics take over. Once the device is powered, the Raspberry Pi will command the Sensit Smart to collect the CV measurements. The Pi will then parse through the results looking for a significant deviation from our baseline measurements. If a deviation of 0.5 microamps or greater is found, the result is positive. Finally, the results are presented on our OLED display.
Our team was able to demonstrate a prototype which made the testing process as streamlined as possible at this stage. Future development could include minimizing total cost, cutting out steps, and using a machine learning model to extract test results. Lastly, the biosensor chip system could possibly be used to diagnose other diseases such as HIV. Overall, our device was able to meet the needs of the sponsor and create a straightforward testing system for detecting syphilis.